All right, welcome back, everyone. This week we are going to talk about three different types of factoring, and the first two are in this assignment. The first two are factoring perfect squares and factoring the difference of squares. And with perfect squares, what that refers to is a perfect square is any number or variable times itself. So, for example, x times x is a perfect square because it equals x squared. Um, 4 times 4 is a perfect square. It equals 16. So that's going to be the key. We're going to have to look for those perfect squares. And really the simplest way to show you how to do this is to just show you how to do it. Um, so if we just look at this first example, what we want to look for is we want to look for a first term that's a perfect square. So x squared is a perfect square because x times x equals x squared. And then a ending term that is a perfect square as well. So 36 is a perfect square because 6 times 6 is 36. All right, so all you have to do is create two binomials, and we're going to put an x in the beginning because x times x is x squared. And then we're going to put 6's at the end because 6 times 6 is 36. And then we just want to verify that this is truly a perfect square. And the way we have to do it is we have to look at that middle term. So if we look at the middle term, I can see it's a negative 12x. And the only way I can take two 6's and turn them into a negative 12 is if I subtract them. So I just need to put minus signs in between here. And you can verify that your answer is correct simply by just distributing. So if we do the distributing, or actually, you know what? Let's use the little box method, and we're going to do it real small here. So we have x minus 6, x minus 6. And so this will kind of help you see what's going on too. With the first box, we have x squared. With the box below that, negative 6x. The one in the upper right-hand corner, negative 6x, and then the one in the lower left-hand or lower right-hand corner is positive 36. So you can see that we've got the negative 12 by adding these two together, and then the first and last term are perfect squares, x squared and 36. Okay, so that's the simplest way to explain how to do it. Let's just do a few more examples, and then we'll just kind of make a list of the rules that we need to follow in order to do this. Okay, so if we look at the next one, this one's a little bit nicer because it's all positive. So that tells us for sure that our binomial is going to have plus signs in it. And we notice that we have a perfect square in the beginning, that's x squared. So that means I can write x's here. And then I have a perfect square at the end, that is 49. I can write 7's here because 7 times 7 is 49. And then I just have to verify that 7 plus 7 is 14. So yes, it is. So I know that that is the correct answer. Okay, so let's keep rolling. We'll do a few more, and then we'll talk about rules that we can apply. So with this one, sometimes we're going to have perfect square trinomials that don't just start off with x squared, but something like 25x squared is still a perfect square because I can multiply 5x by itself and get 25x squared. So it's a perfect square because of that. And then I have a 4 here at the end. That's a perfect square. It's 2 times 2. Again, everything's positive, so that's kind of nice. So I'm going to go ahead and set up my binomials, put the plus signs in there. I'm going to start by putting the 5x here and the 5x here, which is what we want. So we have 5x times 5x is 25x squared. And then to make the 4, we know it's a 2 and a 2, but in this case, it's not so simple to figure out if the 20 is the correct, or if the numbers we have are the correct numbers to make 20. And so we can't just add 2 and 2 together and get 20, and we're only going to get 4 if we add those together. But what we have to remember is that when we're making that 20x, we are actually distributing from here to here and from here to here. So 5x times 2 is 10x, and 2 times 5x is 10x, and that equals 20x. So we know we have the right set of binomials. All right, let's take a look at another one. Now this one throws a little bit of a curveball at us. So if we look at that first term, it's a perfect square because 4m to the fourth is equal to 2m squared times 2m squared, and then the 1 is equal to 1 times 1. And that's sometimes one that people forget. So be careful when you have a 1 there, and remember that it is 1 times 1. This one, I do know something about my signs for this one, because if the last term is positive and the middle term is negative, that means that both binomials are going to be negative. And so I'm going to have a 2m squared here and a 2m squared here. And then I'll have a 1 and a 1. I didn't say this before, but those two negatives do turn into a positive when we multiply them together. So if anybody was wondering back then. But then again, we have to think about that negative 4m squared in the middle there. We don't have the ability to just say -1 plus -1 is -4m squared. That doesn't work, right? So we have to do the distributing again. So we look at this distributing from the first term to the very last term, and that's -2m squared. And then we go the last term in the first binomial to the first term in the last binomial, and it is also -2m squared. And so we get -4m squared, which is what we wanted. So we know that we have the right answer. All right, and then one last one. Whoops. Hello, I can't get my fingers to work on here. Come on. It's too cold. All right. So I haven't had to do it yet because I pretty much know what's going on with these problems. But the one thing that I mentioned last week is that anytime you look at a problem like this, you want to make sure you try to factor out the GCF first, right? And so in this case, there is a GCF. We can notice that all of the terms are even, so I could factor out an even number. All of the terms have an x, so I could also factor out an x. So let's just start by factoring out a 2x. And if you don't know what the greatest common factor between the numbers is, and they're all even, start with 2. And then if you factor that out and you have 3 even numbers left again, well, you're going to have to rethink that and factor something else out after that. But so we'll start with a 2x here. And when I factor a 2x out of 162x to the third, it's 81x squared minus 72x plus 16. Okay, so now the key thing is just to identify, hey, is the first term a perfect square? And the answer is yes, because 9x times 9x is 81x squared. And then is the last term a perfect square? And the answer is yes, because 4 times 4 is 16. So when we write this, one thing that a lot of people might do is forget the 2x. We want to make sure we bring that down and put it in front of our binomials. And so we have a negative middle term, positive last term, so that means they're both negative. And so I have a 9x and a 9x and a 4 and a 4. And we can just verify that that's correct by doing the distributing here. So we have negative 36x and then another negative 36x, and that is equal to negative 72x. So we know we have the right factored form. Okay, so let's think about it. What are the rules we need to follow? Number one, we need to have a first and last term that's a perfect square. All right. So first and last term are perfect squares. I'm going to run out of room for my rules. Number two, middle term is the sum of the last term in the binomials. Okay, but that's not it, right? Because it doesn't always work that it's the sum of the last term in the binomials, right? So it's either the sum of the last term or the sum of, I'm going to run out of space here, the product of the first and last term. Okay, so when I say product, I mean two things multiplied together, right? Holy smokes, I'm using the whole page just for the two rules. I suppose I could have made them smaller. But when I say product, what I mean is that, so for example, in this one, we had to look at the product of 9x and -4, and then -4 and 9x. So that's the product of the first and last term. So that's basically the two rules you need to follow. Make sure that you have the first and last term are perfect squares. Okay, and then the middle term is the sum of the last term in the binomials or the sum of the product of the first and last term. Okay. All right, so that's factoring perfect squares. Okay, so we teach these two together because they're very similar. They both involve squares. So the second part is factoring the difference of squares. And the difference of squares is similar because we want to make sure that we have a perfect square at the beginning and a perfect square at the end. But then one of the key things is we need to see the difference. And the difference means subtraction, which I've highlighted in green there. And you'll notice that with difference of squares, there is no middle term. And there's a reason for that, because the only way we can make 25 negative when we multiply two binomials is if one binomial is positive and the other binomial is negative. The only way we can make x squared is x times x. The simplest way to make 25 is based on the perfect square 5 times 5. Okay, so when we distribute here, we get x squared, and then we get negative 5x, and then we get positive 5x. And that's always what we want, and I hope you can see what's going to happen there, and then we get negative 25. So what we want is we want that negative and positive terms right here, because when we get the negative and positive terms, what happens is they cancel each other out. So we're left with x squared minus 25. And that's where we started, so that's good. All right, so again, it's very similar to what we just did because we're looking at a perfect square for the first and the last term, but then there's no middle term. All right, so let's keep rolling here. So again, here we have a perfect square at the beginning because it's 4x squared. And then we have a perfect square at the end. It's 1. And then we have the difference. Okay, so those are three things you need to check in order to know that this method's going to work. So 4x squared is 2x times 2x. Okay, if it's the difference, I know one of them is going to be positive, one of them is going to be negative. Now, it doesn't matter which one you make positive or negative because they're going to be identical except for the sign. So 1 is just 1 times 1, so I'm just going to put 1s in there. Okay, so it's 2x plus 1 times 2x minus 1. Okay, and so you're going to notice that pattern in all of these. We always have a positive, we always have a negative. They look exactly the same, except the signs are different. All right. Some of you might be worrying about this fraction here. It's 4/9. It's 4 over 9 like this. And don't worry about it because 4 and 9 are both perfect squares. So we can go ahead and highlight that in red. Y squared is good. And then we know we have the difference. And now the question is, what's the square root basically of 4 over 9? Well, we just take the square root of both the numbers. So it's 2 over 3 times 2 over 3. Because 2 times 2 is 4, 3 times 3 is 9. So we're going to use 2/3 in our binomials. So we have y plus 2/3 and y minus 2/3. That wasn't so bad. Don't be afraid of the fractions. All right, sometimes you're going to look at things and say, hey, wait a minute, 6 isn't a perfect square. This doesn't work. X to the 4th is, because that's a perfect square. But if you think about it with variables and exponents, when we have an even exponent, it's always basically a perfect square because we can always divide it in half and multiply it by itself, right? So y to the 6th is equal to y to the 3rd times y to the 3rd. So there we go. We have two things that we multiply together to equal y to the 6th, and they're the same thing, and that's what we want. But then we also need to make sure we have the difference here. And so our binomials are just going to be x squared, because x squared times x squared is x to the 4th. And remember that you're always going to have a plus and a minus. Now, if you want to put the minus first and the plus second, that's perfectly fine. It doesn't matter the order. I think generally speaking, most people are going to put the plus first, but you can do what you want. And then we have y to the 3rd, y to the 3rd. Okay, so that minus sign is really important because that is what allows us to have that middle term cancel. All right, boy, the temperature down here is making my fingers not work on this iPad. Okay, we got the difference. I took advantage of the fact that I had the green highlighter already on. So, whoa, wait a minute. 162 is not a perfect square. Neither is x to the 3rd because it's an odd exponent. And 8x is not a perfect square. But both those numbers are even. Both terms have an x. So remember, we want to think GCF first. So we have 2x because x is the smallest variable, right, with our smallest exponent. So this is, again, it's 81 like we had before, and then minus 4. Okay, so now that's a perfect square. That's a perfect square. We still have the difference, so we can then write our answer. So don't forget that 2x plus sign. If you want to do that to get these set up right away, you could do that. That way you won't forget your plus and your minus. All right, so 81x squared, the square root of that is 9x and 9x. And then we have 2 and 2. So there we go. That's our answer. One more. I see a perfect square. I see another perfect square, but I see a problem right there. This is called the difference of squares. And a plus sign does not allow us to see the difference of squares. So if you see a plus sign between two perfect squares like this, it is something that we would say is not factorable. Okay, all right. That was it. Now you got an assignment. There aren't very many problems, so you should be able to get them done fairly quickly. Maybe we should go over the rules. You want to go over the rules? Let's go over the rules for this one. Here, let's get rid of some of these so we have some space. All right, rules for difference of squares. 1. How did I do that? Circle. First and last term are perfect squares. Same rule, right? Okay, and then the second rule is we have a minus sign between them. Only 2 things to look for. 2 perfect squares, and we have a minus sign. Then you can factor it by difference of squares. All right, give those problems a shot on the assignment, and let me know if you need any help.